Hello, everyone. Thank you for joining our webinar series, MES and Industry 4.0 Success, Learning from Leaders on the Journey. Hope you can hear me. Please let me know if you can't. My name is Chris Parsons from Critical Manufacturing. I'll be your host today. And I want to welcome you all to our third webinar in the series entitled Path to the Autonomous Factory. Our webinar today is being broadcast live, so anything could happen. So please bear with us, and this webinar will take approximately 1 hour. We wanted to host this webinar series because recent analyst research shows that only a small percentage of companies are succeeding in their digital transformation initiatives, such as Industry 4.0, smart manufacturing, and IIoT projects. In fact, only 14%, to be exact, succeed. And people are still talking about digitizing their manufacturing floor and deciding if they should invest or not. Industry-leading companies understand the importance of creating the right strategies and leveraging the right technologies to stay ahead in the market. This webinar series is designed to provide you with some insights and potentially some missing links to success, presented by a mix of the industry experts and heads of manufacturing, operations, and IT that are already on the right path. Before I introduce our featured speaker, there are just a few items to cover on how to participate today. There's a panel on the right-hand side of your screen, and you can select the orange arrow to open and close the panel. So below that, you'll find a very important box where you can submit your questions as you think of them. Paul is going to be answering questions at the end of the presentation today, so we encourage you to do so. The webcast is also going to be recorded and will be available to view on demand in the next few days, and we'll send everybody a link, everybody that registered. So today I have the great pleasure to welcome Paul Straeten, who's the Global Head of Manufacturing IT at Medtronic, one of the biggest names in medical technology with $31 billion in annual revenue. In his role, Paul supports over 70 plants across the globe from top floor to shop floor. Paul has extensive experience in managing global technical organizations and leading the development and implementation of business-driven digital IT programs. He recently shaped a new vision on how to use old and modern technology in manufacturing, where he co-established a smart digital manufacturing strategy for the company. Paul holds a master's in industrial engineering and has an end-to-end understanding on how the manufacturing and supply chain value stream operate, both from a business process and IT data perspective. In today's webinar, Paul will present how Medtronic is managing their transformation to smart digital manufacturing across 4 business segments with highly diverse and complex environments. Stay tuned because Paul has some key messages to share with you all. So let's get to it. I'd like to introduce our featured speaker, Paul Straeten.
Thank you, Chris, for the introduction and having me here. I'm excited to tell our story in this form and hope it's going to be of value for those that are on the same journey than we are or about to start. Before we dive into the content, I would like to share a brief overview about Medtronic for those who are not familiar with our organization. We have been around since the late 1940s, where we began as a medical equipment repair business located in Minneapolis, Minnesota. In the 50s, our founder, Earl Buchan, created the first wearable battery-operated pacemaker, a truly life-saving therapy. Many innovations later, we have evolved to become one of the largest healthcare technology solution companies in the world. Today, we are a medical technology leader offering therapies and solutions that enable greater efficiency, access, and value for the healthcare system, or patients, and the providers, and the people that we serve across the globe. We are truly, I would say, a global company with 19,000 employees operating in more than 150 countries, with more than 350 locations, of which about 75 manufacturing facilities scattered all over the globe. Our principal executive office is based in Dublin, and our operational headquarters is based in Minneapolis. We have a broad product portfolio and harness the power of technology to treat about 70 plus conditions and offer solutions to improve people's life. Our 70 plus therapies are divided over 4 major strategic business units that collectively generate approximately 30 billion in revenue. It's one of the best places to work at, and I'm glad to be part of this unique company. So, as I mentioned in the introduction, I'm by Chris. I will talk today about Medtronic's path as it relates to digitalization. We were obviously not the first one. Many has gone before us, and success is not always the first thing, that comes into the mind when companies talk about their path towards autonomous manufacturing or digitalization. Manufacturing is something unique. It's something special, and it can be fairly complex, especially in the medical device industry or any other regulated industry. A combination of highly automated processes till very labor-intense processes that requires very unique labor skill. We are very highly regulated and of course have zero tolerance for any of the quality issues. I've seen many internal and external plants, and there is not a single plant designed the same. Every plant is unique, which is quite obvious, because designing a pacemaker or a balloon catheter is a completely different process. Before we talk about this, let's take a look at our external environment that we are living in today. We live in a world that we are constantly online. If I look at my daughters, for example, they have 2 modes. They either are online or they're sleeping. So technology isn't special anymore. It's really normal. And this example demonstrates this perfectly. And I bet they're texting, well, I don't hope so, but that they're texting with each other. You might not have seen these signs yet, but these will become the normal road signs as self-driving vehicles will make their entry more broadly. In the last 20 years, we have more access to technology than we could have ever dreamed about. In those days, technology was easy to sell. We introduced technology to users. Users had no clue on how to use this technology. And in some cases, they even used the technology in a complete wrong way. But still, it added value for these users. That's one of the reasons why I love technology. And I spent quite some time with innovative companies. And I can show you an example of a company that's called Aero Vinci. It's a company that's based in the Netherlands and that's refining the future of unmanned systems. These people say driverless cars is so 2013, but an autonomous drone that flies themselves and avoid trees, obstacles, that allows drones to land, recharge, process data, and transmit actionable information to end users autonomously, that's the new normal. And this is why I love talking to these companies. You see the thunder, the technology is fundamentally going to change things. And I get really excited about that. But then, they put me in front of a plant executives to talk about smart digital factory, but they don't always feel as excitement as I do in this. And this is exactly what we have to figure out. How do we convince our executive leaders to get to the next stage? As I said, we're living in a new normal, and you see a lot of amazing technology today. But the question is, when do we have to move? As the famous writer Charles Dickens said, in I think he has an opening phrase, a tale of 2 cities. It's the best of times and the worst of times. We see as a company that we have difficulties in capturing all the information while we have all the technology available. Or machines, sensors, operators, products, they're generating tremendous amount of data, and time is ticking, and the real insight isn't actually happening. But the most fundamental is that we are getting into a world where everything is connected, and that's not an easy thing. The end of linear thinking doesn't work anymore. It means that things are going faster and faster. But have we increased productivity while making all these investments and all these technology out of that? So there is a famous slide. So actually, this is one of my most famous slide. And if you Google it, probably if you Google on Industry 4.0, you probably get a hit of more than 16 million pictures. It's in every sales deck. Every researcher like Gartner has it on there. Software vendors and consulting companies. And when I see these slides, I get suspicious because there are so many out of them and everybody is using it. So there must be something with it. So what is the presenter trying to tell me? Why do I need to go all the way back to the 1700? I think the point is, or the objective is, to articulate that each industry evolution has improved, I would say, that the delivery of high quality products at a lower cost. And if I buy their services or software, it will help me to increase quality and lower cost. As stubborn as I am, I did some research and I discovered that there is a person called Robert Solow. He is a Nobel laureate in economics, and you can Google him. Famously, he quoted in 1987 that you can see the computer age everywhere but in the productivity statistics. Other than a brief bump between 1995 and 2000, the growth in productivity in advanced economics has not kept the pace with the growth in IT spending. It's an interesting research, so check this out. So the question still remains for me, is this a marketing trick? I don't think so. As Industry 4.0 is all about leveraging the existing technology at a higher speed, more affordable, and easier to get access to, Industry 4.0 is more about actually using your technology from the Industry 3.0, but now connecting the dots, collect and correlate all the data, build in the intelligent memory so that we actually can predict things versus being reactive. So for me, one of the biggest changes is to move from a reactive world to a preventive world. Can you imagine you can predict when a machine breaks down or due to weather conditions, certain materials will not be delivered on time or production is automatically rescheduled? I can give you some examples that we have today. There is a big discussion around sterilizers across the globe. There might be riots around sterilizers. When they are there, we might have issues bringing our sterilizers. We're monitoring social media to understand what the impact is and what the impact is on our capacity to get our products sterilized. It's all there. You just have to connect those dots. It's not easy. It's complicated, but the returns are priceless, and productivity will definitely go up. Talking about priceless, like any other company, Medtronic has a very simple bottom line business objectives, and these have not changed over the years. When Earl Buchan founded this company in his garage, we still want to produce high quality products and maximize our supply chain profitability in a fair way so that we have more dollars to invest in R&D for our patients and make our key stakeholders happy about the future of the company, because at the end, that's how we get rewarded. To demonstrate this culture of continuous improvement, sorry, my slide got stuck. We exercise lean manufacturing principles, probably just like thousands of other companies across the globe. For this, we have developed and we have even enhanced a common Medtronic operating system, which is used across all our manufacturing sites. The concept is derived from the famous Toyota production system. The Japanese industrial engineers developed the systems in the 50s. And the core idea behind this is actually quite simple. Relentlessly work on eliminating the waste from your manufacturing process till you have a stable and reliable continuous flow. It's also called like a social technical system. It's all about a joint optimization with a shared emphasis on achievements of both excellence in technical performance and quality in people's work lives. This is one of the key pillars of how we achieve our bottom line objectives today, and most likely most manufacturing companies across the globe. I personally think it's time to enhance this model from the 50s and bring it into the Industry 4.0 world. Let me take you to a slide, and I think there's something missing in the slide. It should have been a curve in dark, but you can see it. So since the 50s, these were the tools and the models used. I've been grown up with it. It basically is a concept for lean optimization. Very traditional, highly labor intense, and it takes lots of time and effort to reach certain maturity level and improvements. So don't get me wrong, the concept is good, but it's also slow and too reactive, because a lot of this stuff works based on stop and fix. My opinion is that the model has not evolved through the industrialization cycles. Machines, tools, networks, products have become much smarter, much more advanced, and have capabilities to collect data. Machine-to-machine connections, linear thinking is not sufficient. So flows become more complex, and we have reached a complexity barrier. And to overcome that complexity and drive even further optimization, different tools and approaches are needed. We have to change the way how we do things. Differently, use sensors, big data, machine learning, and that's what you see in the second curve, but unfortunately it's not visible. It basically demonstrates how you basically can increase the degree of optimization and sustainability by using artificial intelligence. This is what gets executive also excited, and where we see the biggest value for digitalization as it comes more and more affordable. And these benefits even become bigger when we start to apply these techniques earlier in the process of new product introduction. That's even where you get much more value out of that, because you introduced much more mature processes into the production. Where it comes down to is the roadmap towards digital manufacturing finds its roots in the manufacturing operating system. By adapting our social technical manufacturing operating system with a digital mindset. Let me explain this to an example that actually I drew up when I was sitting in a meeting where we had a discussion about an event that we had in the company. So an event for me is anything that can happen around us, being it an abnormality, a temperature change, a new product introduction, etc. There's always the same path and sequence. There's a simple path to that goes through. First, we need to detect. Then we need to get the insight around the event. We need to analyze the event, countermeasure the event, and finally take action and deploy that action to basically solve the event. And this simple process takes a lot of time in manufacturing specifically. And time is our most scarce resources, and it costs money every second, every minute. Downtime costs money. So the question we asked ourselves was, how can we shorten this path? And how can technology play a role in this? So here you can see in this overview what it means if we would apply technology. We can go and basically have the capabilities to adapt the operating system in a combination with lean manufacturing and technology to reduce the time lags between basically the detection of the event, the insights, the analyzing. And the closer we can make those gaps, we get more to a real-time environment. And vision systems, machine learning, and AI can conduct those observations. They can do the analysis. We can have a knowledge base to search for resolutions without slowing or sacrificing production value. And what's even more important is that while you're going through this process, you make your machine even smarter, and it improves the way which it resolves problems as time goes on. So we are applying AI in this way at any scale. And in some cases, we will get to real time. And in some cases, we can convert to autonomous control. And this is how problems get solved in the new world. Now, this maybe sounds complicated, and I understand that in some situations, you think, how do I explain all of this, to my executive leadership? And you can never underestimate the power of having a good analog. So I've run through the gambit of IoT and artificial intelligence rhetoric when talking to our leadership. The biggest challenge for me has always been finding a concrete way to explain how something as abstract as distributed artificial intelligence can be relevant to the factory floor. Our leadership at Medtronic knows the buzz, and it's probably the same for you guys. The buzzwords are all known, and in generally, everybody understands that there is a technology revolution on its way. However, unless you can boil down the abstract concept into a very clearly defined journey and a sequence of steps that deliver tangible value at each state, no one really cares. So the road to clarity for me was actually paved by the autonomous driving industry. During the cast of driverless vehicles, the industry helped us to define distinct levels of autonomy. And you're probably very familiar with that. Depending on how old you are, you maybe still remember where you had non-electrical windows in there. So the mechanization replacing, hand indicators with mechanical indicators. Today, you had human distance control management, which not always worked out well until you hit the wall, to digital distance control. From manual parking to automated parking, so your car fully controls the parking, to interconnection of embedded controls, which eventually has led, to an autonomous driving. It's a very simple step-by-step and eventually connecting all the embedded controls to make basically an autonomous driving vehicle. And the fundamental relevance of these distinctions is that to progress through the levels of autonomous driving, there is a growing complexity of data and intelligence. We need computers to sense, interpret, and react to the real-world scenarios. The vehicles must become more aware of its surrounding and more flexible in its judgments, because not everything is always the same. Things are changing on the road, so they need to have that flexibility and be self-learning. The same is true for autonomous manufacturing. So if we compare that, you see more or less the same steps. And rarely does a machine operate in isolation from another machine. Machine learning applications that deliver real and tangible ROI within the manufacturing environment are based on distributed intelligence models and require continuous interaction between AI algorithms, a data set unique to the machine, including machine data, upstream data, downstream data, but also insights from the factory subject matter experts who innately understand the intricacy of the machines intended to process and have a quality-driven or performance expectation from the process. So it's still also about people, it's data and logic in there. So looking at autonomous manufacturing, you need to understand your current maturity level. And here you can see when you're going through this exercise, how well industry 3.0 has been adopted in your organization. Remember, that's where a lot of computers, software, all these kind of things came out, where you were collecting all that data. Now, it's not a secret. We still have certain plans, where there's a lot of paperwork. So a maturity assessment is a key and critical step in this, because you need to understand where you are. And that's also what we have discovered in the reality when going through this process. It's a jungle out there. And manufacturing is still regarded as a rigid human-led operation with fixed processes. A lot of manual data collection, not automated, not stored digitally. Basically, data history is on paper. And that brings me to, I would say, the number one challenge in digitalization. And if you have made any screenshot at all from today's presentation, I think this is the one you should definitely capture. Don't get blindsided by the nice tools, AR glasses, everything that's out there. The question you need to ask yourself first is, do we have the data? Is the data reliable? Can we contextualize the data and get intelligence out of it so that we can send the right information to that AR glass that we really like, so that we can make the right decisions? So a unified plant data management is mandatory, and you need to agree on certain standards, else you will not be able, to meet your successes and your objectives in your digital journey. So if we look at the disciplined path, not only, if you define that path in a way that it is understood by everybody, then it allows you to actually get to deliver tangible and immediate ROI. It also helps you, for greater adoption. It is important to provide a compass to the organization. What is the problem you want to solve? Where do you want to head to? And how are we going to do that? Are key questions. And we all know that none of this works unless, the collective team is on board and excited and see the value. This is really a team sport. So one of the first steps is to define true north. Where do we want to be in 3 years, and how do we get there? Identify the key few capabilities that are needed and common across the plants. A simple rule that I use: it's better to improve 1% productivity in 50 plants than 5% in one plant. So look for the commonalities in there for the capabilities. And we have identified 5 to 6 capabilities at Medtronic that we are working on and we have full focus on. So to identify these capabilities, it's important to engage with the sites. Conduct the awareness workshops, make them familiar, what's all possible, the art of possibilities in there. Work with them to understand where they are on the maturity level and understand, what is common across the plants. And for this process, we use an external partner. In our case, it was Deloitte who helped us to go through these processes. And we visited quite some plants to get significant insights on their maturity level. And we have looked at cost calculations from all the LBM that was applied to the plants, very detailed analysis, because that was basically the background on the information on why we were doing things. But also we found areas where we say, we're not going to touch that. It's not worthwhile to touch these things. Now, once you have eventually identified the key capabilities, as I said, not every plant is the same. They're all designed differently. You need to prioritize and sequence by plant what their journey is going to look like. Don't try to copy existing processes and try to automate or digitize these, but rather look at, in our case, I don't like the word best practice. If I talk about best practice, I talk about Medtronic best practices. So we have looked at all the processes and see how can we make a Medtronic best practice out of that. And once we have defined that, we're going to look at, where do we have technology gaps in there? Because we have a lot of technology, and if you could have a view on our shelves, we have probably almost any software that's out there in the world. So that's not our problem. Our problem is, how do you architect that and make a common architecture? Because this is not an architecture by plant, because remember, this is a connected world. So you need to figure out a way, how can you find standardization and alignment? It's becoming more and more critical. Now, I'm not saying that everything needs to be standardized, because you can use connectivity and integration capabilities. But there are certain components where you need to agree upon that you're going to standardize. And you need to maintain and manage that architecture, I would say, through a very strong governance. So that we are all being able to leverage those same highways, these same data capabilities, machine learning across the globe. So once you have that identified, the next important step is here, select an implementation model. We empower the local sites to manage their deployments themselves. As for us, this is the first step towards ownership, and it makes them accountable for the benefits realization. From a global perspective, we purely govern the capabilities. And for us, clearly, it's not an IT project, it's not an OT project, it's not an operational excellence project, it's a team sport, it's a joint project and program whereby the manufacturing plant is in the lead. Even stronger, it's the line managers and the operators who are actually driving this, because they have the best insights on what's happening on the production floor and how things can get improved. Now, the last step, and we are still in process of defining an effective operating model. So today we still run more in a kind of project mode, but sooner or later, we need to start transforming from this project mode into an operating mode. So long term, we are going to set up a couple of, digital manufacturing capability centers that are focused on certain expertise areas, like additive manufacturing or vision inspection, who basically build up that expertise and provide that and hand that over to the manufacturing site so they can deploy these type of capabilities, so that we don't reinvent over 70 plants the same similar vision inspection systems or certain machine learnings or artificial intelligence. That is where we see that we can benefit from the leverage, and it is probably also the area where our talented capability owners will reside. And these are the people that have a passion for continuous improvement and digitalization. So the intent of these centers are to solve real life production challenges and experiment with new digital technology without concern for impacting ongoing operations. So far, this journey has been very positive for us. I give the example around the current COVID situation. One of our capabilities was focused on digitizing the support and maintenance processes, and that became very handy in the current environment that we are operating. And we have been able to quickly deploy to sites where they were of big need of having engineers to remotely support the production line. So the model works, and we have taken already some huge advantages of this model. What I want to share with you as a next step is some of the key takeaways. We started this presentation that technology is not special anymore. It's the new normal. Industry 4.0 means for us real opportunity to increase productivity by leveraging the technology in the right way and embed it into our manufacturing operating systems, DNA. So don't wait start now and take an enterprise approach. Remember, it's about connectivity, and you don't want to miss opportunities if you're going to do this in silos. These days, organizations have become extremely complex, which on its own hampers already progress, because everybody wants to be involved, everybody wants to have a say in it. For us, most of the people today that are in that complex organization are concentrated on what they do today. And that's good. We appreciate that. But for this, you need people that are every day focused on the future. These are the people that you need, that work in this mode, that think in this mode, and have the time to operate in this mode. The data, I touched upon that, it's the lifeblood for success. Without the data, nothing will work. In fact, the success will rely on the amount of historical data that you already have. If you want to create machine learning or vision inspection systems, you need to have a lot of historical data. You need to feed the machine to basically train the machine. So the longer you wait, the longer it takes you to build up that historical information. Data is stored in many, many databases in different formats and different data types. So be ready to have an excellent and reliable integration hub so that you can orchestrate and contextualize the data across your manufacturing plants. This is something that we have discovered as being a big pain point today, that we don't have that, I would say, as robust as we had hoped we had. And it's quite normal because Medtronic has grown based on a lot of acquisitions. And in most cases, manufacturing is left alone. So that's something where we had to invest in to make those kind of integrations. The other point I want to make here is that this is not a management initiative. Operators and line managers are the owners. They know perfectly how their line runs and are the best source to make improvements and implement the improvements, but also embrace that technology. And they're willing to do that. Our workforce population is changing. Some of them have more advanced capabilities at home than at the manufacturing plant at our work. So they are expecting different workplaces in terms of how they consume information or what information that they get. They're not willing to write information on a piece of paper or start first collecting information and then make a calculation. They expect the machines to talk, and I'm waiting for the first person that comes to me and asks, Paul, when can we have Siri on the production floor? Because I don't want to use the touchscreens. I just want to talk and get an answer. That's what I'm doing at home as well. So we need to be prepared for that. Design modular building blocks, not monolithical monsters that can't be scaled or reused. Your enterprise architecture team, both on an OT and an IT, are critical in your success. They need to help you to design very modular-based building blocks that can be deployed in a very modular fashion, because not all plans are designed the same, but they can use certain modular blocks to basically build that capability that they need. A key aspect and a key decision in your architecture. Stop pioneering and testing. We've done that. We've done a lot of tests, etc. It only becomes interesting when you really bring it to life. You need to take the leadership and say, we get started. And every day you wait, you get further behind. It's the new normal. I think I showed you at the entrance, at the beginning of the presentation, what's already out there. It's not abnormal, it's normal, it's there. So use it. I would say from an final comment that I would like to make is around the linchpin in this digital revolution is also, and I've been very passionate about this, is a new breed of manufacturing execution systems. that connects shop floor with top floor, and it will be the must-have backbone for a smart digital manufacturing, because you need to be able to contextualize your data. The system needs to be modular. It needs to be easy to use. The engineers, as I just was talking about, we have no benefit as a company if every time we want to make a change on the production floor, because remember, we're talking about continuous improvement. Our objective is to basically day by day improve our profitability through continuous improvement. And every time if I need an IT guy that is not available, or I need to wait, is a delay on getting access to this profitability. So that means that the systems also need to be able to be controlled by engineering departments and not by IT. They need to be easy to use. So that's also where user experience comes into play. They need to be self-explainable. I never had a training for Facebook. It needs to be as easy as my father of 85 years is using his iPad today. That is how you can basically drive adoption and drive that continuous improvement. If you make it too complicated, you put a barrier in front of you. So we have found in critical manufacturing also that partnership. Francisco and I, we had similar line of thinking, or thought leadership around innovation and the creativity in delivering next generation MES capability, that goes beyond the traditional ones, is a common theme that we strive for. And I've been grown up as an industrial engineer with traditional operating systems, and it was successful. But due to my career opportunity, switch, call it whatever you want, I've also seen the new normal in technology and how this can complement these traditional operating systems for the better. And I can only encourage plant leaders to embrace this new approach rapidly. The world is getting more and more connected and thereby more complex. So to some extent, you have no choice to stay competitive as a manufacturing company. With that, I wish you success with your journey. I would like to thank you for your attention and interest, and happy to answer any questions that might be out there.
Thank you, Paul. That was a very inspiring presentation. So at this time, we're going to go through some of the questions that you've asked during the presentation. And I've got to say that there are way too many questions for us to cover today. So I'm just going to basically go through 3 or 4 or 5, depending on Paul as they came in, and we'll see where we go with the time. So, Paul, are you ready for the first question?
Yep, sure.
Okay, so we have one which is, which unexpected outcomes did you get out of your first advanced plant automation projects?
It's a good question. Sure, that's the first one, or?
That's the first one, but if you want to go back to that one, I can ask another one.
So I think the unexpected events, I would rather say we had, they're twofold. In some cases you find unexpected events that basically fall into the category of positive, and others are more in the negative. And I think one of the areas where it becomes more tricky in terms of unexpected events is if you are using a lot of, and I give this as an example, a lot of automation on your shop floor, like PLCs. They're typically not, designed and built specifically, if they are a little bit older, to tag the information in a way that it's easy digestible. So there's a lot of work to basically standardize the definitions in there to get some meaningful information out of that. Now, even when you want to do that, one of the concerns we had, as we are operating in a very highly validated environment, you don't want to go into another validation cycle of 3-4 months, because that's completely against if you want to deliver rapidly with speed. So these were some of the events that we initially, I would say, not counted for, that some of these complexities would, I would say, be created where we eventually didn't get the data that we expected to get, and that we had to do a lot of homework to get to that stage. On the positive side, we also received information and insights that we didn't have. And it can even be as simple that we had some quality issues that was impacting multiple plants. The one that we digitized, we had the information in 10 minutes. The plan that we haven't digitized, it took us 2 weeks. So these are surprises, because we didn't design and build this for having a quality event, because that's the last thing that we want. But here, surprisingly, we were able to get information quite quickly out of this plant to analyze, and quickly understood that it was not in this plant, but it was actually more downstream. And that's actually where the challenges became. So there are some ups and downs in this.
Thanks, Paul. We'll go into the second question. And the question is, if an acquisition of a set of factories comes with existing systems, how do you plan the software standardization towards a more unified enterprise landscape?
You sure this is not a question from one of my Medtronic colleagues?
No, let me check. No, it's not.
It's a very, very good question. And I think for me, it starts with the acquisition agreements that you make. So I think this is a topic that we have in general, that how do you basically align and get an agreement what to do when you acquire a company and you want to integrate it? Is that from day one full integration and you basically forced to go to standard? But that comes with a cost associated to that. So it would be the ideal state, because the other problem that you get is you basically push your problem down the road. And I'm sure it's same and similar in other companies. Once the acquisition has completed, then any other improvements fall in the acquiring BU on their regular P&L. So there is no acquisition budget anymore. So we are very, I would say at this moment, very sharp on these acquisitions to actually manage these things in a better way. There is not a simple, straightforward answer on that, because it also doesn't make sense, if they have mature systems and it's working well, to start replacing these systems. So this is where we're looking more at integration. So we're getting more and more keen and getting more flexible ways to bring them on board through integration. And that's why I'm saying that the manufacturing integration bus is a very critical tool to have in your toolbox if you are talking about digitalization, because you don't always have the money just to start rip and replace your manufacturing site's current capabilities.
It makes perfect sense. I'll follow that one actually with a question related to Industry 4.0, and especially for your plants that have almost no systems or manual paper-based systems. Where do you start? Is it connectivity? Is it MES? Or is it something else?
MES, and I think I mentioned that actually in the last slide, that MES is a critical component in there, because before you need to have data to contextualize, and to have that data, you need to have an MES system in place where you capture that information in an easy way. So that's for us the most critical component when you start with digitalization. In fact, all the plans where we have started to roll out the capabilities do have an MES system. So that is actually the prerequisite for actually go to the next level.
And you mentioned data in your comments. Do you have a recommendation for data governance program, or is there a data governance process in the MES software?
No, it's very, very good question. And actually, next to this initiative, we have a global initiative. It's called Product DNA, because we recognize the importance of that. So this is really going hand in hand. Because without going too broadly, eventually we want to have this environment between the product and the process, this cyber physical environment where we have both ends in that. So we know that product data, and we did a kind of assessment where product data is used across the company, all the way from, I would say, the sales and marketing, the customer service, manufacturing, etc. So we have a separate initiative to that. That's actually a very good question. And I would recommend to start also with, a program called Product DNA. We call it Product DNA, to start cleaning up and get definitions around your product data.
Okay. So the next question, Paul, is related to standardization and some of the comments you made around standardization. Do you think that standards will be managed internally within individual companies, or do you think standards need to be collaboratively developed by industry standard organizations for the larger ecosystem to operate?
I can be quick on that. It's collaboratively. They need to be developed. At the end, you're talking here about connectivity, so you can't just operate in isolation in here. It's the same in the beginning of the EDI age. You need to agree on standards in this. So we're looking at OPCs and all kind of like B2 MML type of standards that we want to use, because without that it becomes only more complicated. I'm not saying it's not doable, but you create a significant complexity on you if you don't collaborate and do this in a collaborative way. Even when you buy machines or equipment, you're depending on external, so you don't want to write protocols or equipment controllers for every piece of equipment that you buy. You would like to have that more standardized. And in fact, it's one of the biggest challenges. And I'm sure if there are people here on the call from a regulated environment where validation is important, it's really a pain if you have no standardization in that space. And even on the way how you architect them and how tight they are connected into your process, some things you really have to think about, because if you embed it too closely, your connectivity and etc., you basically have a huge cost in managing and maintaining these connectivity areas.
So do you have a few more questions in you, Paul? Shall I keep going?
Yeah, keep going.
Yeah, keep going. Okay, we have a great question related to some of your early slides around executive sponsorships. How do you build an ROI analysis, or how did you build an ROI analysis for convincing Medtronic's upper management to invest in a long-term vision and plan? It could be a long answer. Let me know if you want to think about that and need another question.
No, I think it's maybe an interesting one to share, because maybe we had a little bit unconventional approach in this. Because I think first of all you need to do your homework and find a person that, and I think I mentioned that in here, a leader, an executive in your company that doesn't only think about today and work from yesterday or maybe next day, but somebody who's really looking ahead. You need to find this person who is also visionary, and you can identify that already, like how he is managing his operation. Is he already interested in all these CNC machines with robotics and these kind of things? You will find those persons, and then what you do, and I will say I've been very pleased that our senior executive responsible for CVG operations is a person like that. And what we did is we took him on a journey. So together with my co-lead in this program on the business side, we took him on a journey where we visited, for example, McLaren in the UK. We went to the Advanced Manufacturing Research Center in Sheffield. We visited Apple. So it's by showing, what the potential is that drives some of the enthusiasm to start working on business cases. So, just coming in and presenting is not sufficient. As I said, you need to explain it and you need to correlate it also, to your operating system, because manufacturing companies have tons of engineers, process engineers, continuous improvements in there, and they basically, you need to take them on the ride. So how do you explain and tell that story and show them how these things complement each other? And that's only by doing visualization. Go there, go out, show them what's out there. I think McLaren has basically opened their eyes and they can translate that. We were sitting in the Formula One cockpit room and it was a simulation of a race in which they showed, because a Formula car has tremendous number of sensors, and they showed all the data, and they had to make a decision to change the tires for a certain round. And tire degradation is a key aspect in winning or losing. And there was this lady, I think she was 23 years old, who made a decision. And the way how it works, you have a crew on the field, on the racetrack, and you have a crew back home in your data center. And this lady is in the data center and she makes in a split second the decision, this driver needs to come in right now. So how does the business see this? They are looking at that and they look around and, the session was ended and they say, hey, that's our manufacturing control tower. So they correlate exactly, how they can use this data and this same technology. So now they get interested in, hey, these sensors, how are we doing that? How are you collecting that data? And that has helped us to basically get started with this. You need to have the enthusiasm in there, then prove out where the value is to basically build those business cases.
Well, thank you, Paul. I think that's all the questions we have time for today. So we do have a lot of questions, and if your question's not answered because of these time constraints, we're right up on the hour now. Don't worry, we will reply to every question by email in the coming days. So you will get your question answered. So Paul, thank you again for your inspiring presentation. We really appreciate you joining us today. But before we leave today, I just want to invite everybody to keep registering for webinars in the series. You'll see that the next webinar that we have is with Martin Kelman on, he's from the Chief Digital Transformation Officer at ATS Applied Systems. And his presentation will be 5 steps to digital transformation on July 14th. So you can register at webinars.criticalmanufacturing.com and keep checking back because we will be adding more throughout the year. And with that, I want to thank everybody for joining and for staying with us for the whole hour. Thank you again, Paul. And with that, we will close the webinar. Thank you.
Thank you, everybody. Bye.
Thank you.